Hello guys, welcome to Top Math, YouTube channel which discusses solutions to various math competition problems given in the past several years and given locally and internationally. So here is our problem for today. Consider the arithmetic progression 1, 9, 17, 25, 33, and so on until 2025. A number n is the sum of 17 distinct elements of the arithmetic progression. How many distinct possible values of n are there? Okay. The AP, the arithmetic progression, is generated by a sub n equals 1 plus 8 times n minus 1, with the first term being 1 and the last term, which is actually the 254th term, is equal to 2025. Let S1 be the smallest value of n. And S sub n be the largest value of n. Since the AP is increasing, since the arithmetic progression is an increasing sequence, S1, the smallest value of n, S1, must be the sum of the first 17 terms of the arithmetic progression. So it's equal to the sum of the AI's, I from 1 to 17, which is equal to 17 over 2 times a sub 1 plus a sub 17, which is equal to 17 over 2 times 1 plus 8 times 16, which is equal to 17 over 2 times 2 plus 8 times 16, which is equal to 17 times 1 plus 4 times 16, or 17 times 65, which is equal to 1105. So this is the smallest value of n, and the largest value must be the sum of the last 17 terms, and they are the sum of I from 238 to 254, which is equal to 17 over 2 times 1 plus 8 times 237 plus 1 plus 8 times 253. And without going into the details, this sum is equal to 17 times 1961, which is equal to 33,337. So these are our smallest and largest values of n. So the question now is, how many other values are between these two values? Okay, so that we'll have an idea, let's look at the second smallest value. So S2 is the second smallest value, and it is equal to the first 16 elements, terms of the sequence, and then we replace the A sub 17 with A sub 18. Okay, so we have the first sum from 1 to 16. You have 16 over 2 times A sub 1 plus A sub 16, and then A sub 18 is 1 plus 8 times 17. But of course, this is equal to, this is 8, A sub 1 is 1, A sub 16 is 1 plus 8 times 15, and this is 1 plus 8 times 17. And again, without going into the details, the first is equal to 976, and the second is 137, which is equal to 1113. So this value, that's the second largest value. And let's look at the third smallest. It's S3. This is equal to again from 1 to 16 plus, replace the A sub 18 with A sub 19. So we already know from the previous calculation that the sum of AI from 1 to 16 is 976. Okay, that one, 976, and then A sub 19 is 1 plus 8 times 18. 19 minus 1 is 18. Okay. And this gives us 976 plus 145, which is equal to 1121. Now, observe that S2 minus S1 equals 1113 minus S1 is 1105, and the difference is 8. Also, S3 minus S2 is equal to 1121 minus 1113 is also 8. So this tells us that sums SI also form an arithmetic progression. Thus, the SIs also form thus the S sub i's also form an arithmetic progression with common difference D, which is also 8, just like in the original arithmetic progression. Therefore, Sn, the largest, is equal to the first term, S1, plus 8 times n minus 1. And S1 is 1105 plus 8 times n minus 1, and this is equal to the largest is 33,337, from which we obtain n minus 1 equals 32,232 over 8, and this is equal to 4,029. Therefore, n is equal to 4,029 plus 1 equals 4,030, and this is the number of values of possible n's. So this is This is the number of possible values. Values of n. Okay, there's another way of arriving at the same answer, and I would like to show it here. So the first one is solution 1, and then we have solution number 2. And in solution number 2, we argue that since each of 17 numbers is of the form the form 1 plus 8x. The sum of any 17 of them is of the form S. Okay, I'll just write it here. S equals 17 plus 8 times x1 plus x2 plus and so on plus x sub 17, where x sub 1, x sub 2, x sub 3, and so on up to x sub 17 are distinct elements of the set 0, 1, 2, 3 until 253. Now, let x be equal to the sum of the xi's I from 1 to 17. This is capital X. Okay. Then x is between these two numbers. 16 times 17 over 2. Okay. That's the smallest possible value of x. And the largest possible value of x is 17 over 2 times 253 plus 237. Which is the same as x is between 136 and 4,165. Therefore, there are 4,165 minus 136 plus 1, which is equal to 4,030 such possible values of n, or such values of n. Or I will not include the word such na lang. So 4,030 possible values of n. And of course, we can see that this agrees with our answer in the first, using the first solution. Okay, so we have this 4,030. Now, let me include this note. It is incorrect to just compute uh, 254 taking 17. Because there are distinct 17 element sets. There are distinct 17 element sets from the AP whose element sum are equal. For example, consider the following sets. Consider the sets A whose elements are A sub 3, A sub 4, and so on until A sub 17. So there are only 15 elements here, but we need 2 more to make it 17. So we consider these 2 other elements, A sub 2 and A sub 18. So there are now 17 elements. And the set B of terms from the arithmetic progression, we have also A sub 3, A sub 4, and so on until A sub 17. Again, there are only 15 elements here, so we add 2 more, and in particular we add A sub 1 and A sub 19. Okay, now let X be the sum of the elements AI coming from A. So that's how we write it. And this means that this is the sum of the i's from 3 to 17, and this is a separate sum, and we have two more to add, and these are a sub 2 and a sub 18. And y is equal to the sum of all the AIs coming from B. Therefore, this is the sum of all the AIs from 3 to 17. Okay, again, that's a separate sum, plus a sub 1 plus a sub 19. Now, observe that a sub 2 plus a sub 18 is equal to a sub 1 plus 8, while a sub 18 is a sub 1 plus 8 times 17. So this gives us 2a sub 1 plus, this is a sub 1 plus 8 times 18. Okay, let me write this properly. This is 2a sub 1, and a sub 2, a sub 1, a sub 1 plus a sub 19 is equal to a sub 1 plus a sub 1 plus 8 times 18, 19 minus 1 is 18. So we also have 2 times a sub 1 plus 8 times 18. It follows that x equals y, even though the sets A and B are not equal. So that's the reason why that it is incorrect to just compute 254 taken 17 to be the number of possible sums of any 17 element subset of the arithmetic progression. Okay, so that's it for this video, and our challenge is the sequence AN consisting of a sub 0, a sub 1, a sub 2, and so on, of real numbers that satisfy the recursive relation n times n plus 1 times a sub n plus 1 plus n minus 2 times a sub n minus 1 equals n times n minus 1 times a sub n for all natural numbers n, where a sub 0 equals a sub 1 equals 1. Calculate the sum of the ratio a sub n minus 1 over a sub n from n equals 1 to n equals 2024. So that's it for now. I hope you enjoyed our discussion, and you learned something new. So goodbye for now, and may God bless you.